Yeah, so for ionization energy, know that when you're taking an electron away from a atom, you're basically needing a lot of energy to do that. So that means that that reaction would absorb energy, so that way that the electron can be pulled away from it. And the ionization energy for that would just be given through that. And then when you are giving an electron to something, that's also going to be the opposite of absorbing energy. So it'll release energy, I guess. So that's just something to know. And the ionization energy is the same, and it's you don't need to change the negative or positive, just keep the same sign. So this question asks you how to rank the effective nuclear charge. Just know that the rightmost is going to have the highest effective nuclear charge. It has the highest pool of electrons towards its nucleus. You can see fluorine has the highest compared to the lowest of boron. When you're writing the electron configuration, then when it has +1, you basically just add an electron. Oh, sorry, you remove an electron. Um, so they give you this electron configuration. So you know that your noble gas core is neon, and then you know you have a total of 2 electrons. So you go to 11, 12, and then you see that this is a charge of +1, right? So that means that that original element had 1 electron removed from it. So your answer would be the 13th one, aluminum +1, because they tell you there that you had a +1. So it's something another element to consider. Another one, so just remember for this problem, like to know the total number of electrons, you add the amount of electrons that that noble gas core has with the rest of your electron configuration electrons. So this question, it talks about periodic table trends. Remember, the left side are our metals and our right side are our non-metals. So we know that metals like to lose their electrons and become cations, and then um, our non-metals, they like to gain electrons and become anions. So ionization potential, it basically is asking you what takes for this first question, what takes more energy um to take an electron. And that would be element Y, because they really don't want to lose their electron. They want to gain their electron. They're almost close to filling that noble gas core by adding an electron. So then the second question is asking you which takes less energy to ionize. And then that's that metal, because once it loses electrons, it gets closer to getting to become a noble gas core. And it's just a trend to remember. All right, this talks about oxidation states of group 7A. Oxidation state is basically what happens to the charge of an atom when its electron has either been given, taken or given to it. So something to remember about this is when you're looking at the periodic table, you ignore the middle block, the transition metals. So you go from 1A to 2A, and you skip that middle block to 3A, and then you go to 8A. So let's look at 7A. That's our atom. And then you should know that it could only receive 1 electron to become a noble gas. So that's its potential maximum potential oxidation state for negatives. And then for positives, it can lose 7 electrons, because that's the amount of valence electrons available. Yeah. Question 17. So it's asking you that it has the same isoelectronic. That basically means the same amount of electrons as an unreactive period three element. So you go to period three, and that's going to be here, and that's argon. And it's unreactive because it's a noble gas. They don't want to lose or gain electrons. They're unreactive. And the compound has an element that has a plus one ion and a negative one ion. So it's basically um chlorine and potassium. Chlorine gained an electron, which is going to be the negative one ion, and then potassium lost an electron, which is the plus one ion. And then you just remember the cation that lost the electron first, and then the anion second. All right, question 19. So you have two ions and they're next to each other. So we have sodium, chlorine, and sodium on the left side. And you go into this formula, which is basically the diameter is equal to the radius of the sodium and the radius of the other sodium. And then you get the radius times two of chlorine and chlorine. And so that's going to give you the distance between two sodium ions. And then basically you can rewrite it as so using algebra. And then you know from the problem that the radius of sodium is equal to that amount of the radius of fluorine. So you basically rewrite this into there, and basically you know that the coefficient of what's already in that formula is going to be added into 0.767, and then you get that number. So you're here, and then next you divide by the okay, so at this point you have that, and then I think they just multiply or multiply by they divide RCL, so you get 1 over RCL, and then they divide by D, and so you get that. And I think like somehow they were able to flip it so that somehow they got RCL, and then they got D over 2 divided by times 1.923. I'm not sure how the algebra works, but I'm pretty sure that's what they did. After that, you just times your value by 0.923 from the problem. They told you that that atom's radius is going to be that amount of the other's radius, so you just multiply it to get it. Final question. So we remember that ionization energy is the energy it takes to either take or I think take an electron, actually. So then it asks you for group 15. So we know that as you go down, it takes more energy to take an electron because, oh, sorry, wait a minute. Okay. So basically, as you go down, it's easier to take an electron. So it has the lowest ionization energy. Like you can literally just like grab it very easily because remember the effective nuclear charge decreases as you go down because those there's more electrons that are blocking the outer electrons. So that means those outer electrons are able to go further from the nucleus. It has less of a pull towards the nucleus. So basically, because it's higher up, that means that the ionization energy is going to be higher, and it's going to take more ionization energy to take an electron from that higher element than it is from that lower element of that same column. And then in period 4, so row 4, we know that as you go to the right, the the effective nuclear charge increases, which means that pull from that nucleus with the protons is pulling those outer electrons tighter. So it's going to take you more energy to take away electrons as you go to the right of that row of that period. But as you are on the leftmost side, it's going to take less energy because that effective nuclear charge is lower as you go to the left than it is from the right.